Hello everyone, welcome back to Algebra 1 with Miss Betsy. Today we're going to be talking about a couple of different special products when we are multiplying together binomials, and we're going to see that these will help us if we can recognize a pattern. We can sometimes save a little bit of time rather than always needing to use the FOIL method of multiplying together two binomials. This video is driven by the second edition version of Algebra 1 for Christian schools. It looks like this. Third edition differs significantly. The numbering will be different, but you can still use this video. You can use it again regardless of what algebra text you're using. So let's go ahead and pray and get started. Father, thank you for the beauty of the world around us and for the little bit of snow that we had yesterday and for the chance to enjoy a warm day in front of the fire today. Father, help us to learn those things that you would have us to learn, to be attentive to you and to listen closely for your voice as we go about the day. In Jesus' name, amen. Okay, a couple of old jokes for you. These are so bad, but still have to be reminded of them occasionally. What is worse than finding a worm in your apple? And I may have actually said this in class. Well, of course, worse than one worm is finding half of a worm. And why did Cinderella get kicked out of the soccer game? She got kicked out because she ran away from the ball. And what is a race car driver's favorite meal? Fast food. So all I can think is that poor race car driver. So we're on section 8.7 if you have the second edition of the text. This is on page 347. And it is entitled Special Products. And the first special product that we are going to be dealing with is when we square a binomial. And a binomial is just has two terms in it, and that is being used as a factor twice, multiplying it against itself, and this is what we call squaring a binomial. Similarly to if we said that we wanted to square 4, we would take 4 and we would use it as a factor twice and we would end up with 16. Now what we've learned up to this point when we are multiplying is we have learned how to use FOIL, or it's an acronym that tells us to multiply first, outer, inner, and last terms together, and that allows us to come up with the product of two binomials. So first, if we have x plus 2, quantity squared. Quantity squared, we're going to say that is, we can write this as x plus 2 times the quantity x plus 2. FOIL tells us that we multiply first terms together. X times x is x squared. Outside, 2 times x is 2x. The inner terms are multiplied together to give us another 2x. And then finally, the last terms are multiplied together for plus 4. We collect like terms, and we have x squared plus 4x plus 4. And if we were to go ahead and do this again using the second example that we have in the book, we have the quantity 3x minus 4. And we want to square that one. Quantity 3x minus 4 squared. The parentheses tell us that we're going to take that entire binomial and we're going to use it as a factor twice. 3x minus 4 times the quantity 3x minus 4. FOIL, first, outside, inside, and last. That's the acronym that we used so that we could multiply together two binomials horizontally rather than vertically, because it's easier in algebra to multiply these things together horizontally. We multiply the first terms together, 3x times 3x, 9x squared. Outside terms, 3x times a negative 4, negative 12x. Inside terms, negative 4 times 3x is another negative 12x. Outside terms, or the last terms rather, negative 4 times a negative 4 is a positive 16, which results in 9x squared minus 24x plus 16. Okay? Very straightforward use of FOIL. Now the last one that I want to use here is our general pattern. What's it going to be when we square a binomial? Instead of putting any numbers in here, let's just use the quantity a plus b squared and have this totally general a plus b times the quantity a plus b and see what we end up with. Same rules. A times a is a squared for the outer. For the first terms, we multiply the outer terms together, a times b. We multiply the inner terms together, b times a, and we're going to put that in alphabetical order. So we have another ab, and then we multiply our last terms together and we have b squared. When we collect like terms, we have a squared plus 2ab plus b squared. And this is what we want to look at, and we want to see if there's a pattern. A squared plus 2ab plus b squared. What is that really telling us? Let me get some of this mess out of the way here. Let's look at this and see what we have. Well, a squared, that's the first term, and that's a totally pitiful marker there. I think I did that last time. That's the first term, and it's been squared, right? A squared. B squared right here is the last term. And we squared that term. What do we have with this 2ab? What do we do? Well, we have 2 times the product. We have a times b, and we doubled it. So we have twice the product of both the terms. So, simply using straight algebra, we take our first term and we square it. We multiply together those 2 terms and we double it. We take the last term and we square it. Let's see what happens here. Right here is where we broke this multiplication out and we used first outside, inside, last. But let's look at our answer. This right here is the first term squared, x squared. This plus 4 is the last term squared. What do we say the middle was? Twice the product of the 2 terms. The product of these 2 terms, x times 2, is 2x times 2 is 4x. So that fits the pattern. What about over here? We said that our general form should be we take this first term and square. 3x times 3x is 9x squared. We take our last term and we square it. Negative 4 times, shouldn't that be a negative 16? No, we have a negative 4 times a negative 4. Negative times negative is positive. So we have our first term squared and we have our last term squared. Now let's look at this middle term here. What should it be? It should be twice the product of the terms. What is the product of 3x and a negative 4? 3x times negative 4 is a negative 12x. 2 times that is negative 24x. So what they are showing you is that when you have the square of a binomial, you don't have to write out this method of using FOIL. You can, but you don't need to. So let me show you these two right next to each other. The only thing that I'm going to leave up is our little illustration here that tells us what to do when we square a binomial. So example 4 says 2x minus 5 quantity squared. 2x minus 5 quantity squared. If we recognize that this is the square of a binomial, then we can use our rule here that says that the way to find this product, you take the first term and you square. 2x times 2x is 4x squared. You multiply these two terms together. 2x times the negative 5 gives you a negative 10x, and then you double it. Negative 20x. Then you take the last term and you square it. Negative 5 times the negative 5 is a positive 25. When you recognize that you have the square of a binomial, there is no extra work for you to show. But let's say, okay, I don't remember the pattern. Can I go ahead and use that simply by foiling? Well, you need to be able to. Let's see what happens. 2x minus 5 times the quantity 2x minus 5. With FOIL, multiply the first terms together. 2 times 2, 4x squared. Outer terms, 2x times negative 5, negative 10x. Inner terms, negative 10x. Last terms, negative 5 times the negative 5, positive 25. Collect like terms, minus 20x plus 25. And you see that, as must be the case, whether you use the formula, you recognize the pattern of finding the product of, well, finding the square of a binomial, whether you recognize the pattern or you use FOIL, you get the same answer. And this is what they call a special product. It's a special product because there is an abbreviated method of coming up with your solution. So the square of a binomial is a special product. The second special product that we want to talk about today is how we obtain the difference of two squares. And you're going to love the difference of two squares as you move on because it makes your factoring very easy. So let's see what happens, because what we've used here is we have squared a binomial when we had a positive sign. We squared a binomial that had a negative sign. Both of the factors were the same, but what happens if we have something that's very similar to this but not exactly the same? What if the only difference in the two factors that we are multiplying together is the sign inside them? X minus 4, x plus 4. And over here, this is going to be the a plus b times the quantity a minus b is going to give us our pattern. What happens when we FOIL? X times x is x squared. Outer is plus 4x. Inner, minus 4x. And last, negative 4 times a positive 4 minus 16. Collect like terms. in the outer partial product and the inner partial product cancel each other out, and we have x squared minus 16. Let's go ahead and do another example. Our next example is 3x plus 5, 3x minus 5. 3x plus 5, the binomial, times the binomial 3x minus 5. Okay? Outer, the first terms multiplied together, 9x squared. The outside, 3x times a negative 5 is a negative 15x. When we multiply our inner terms together, positive times positive is a plus 15x. You multiply our last terms together, positive times negative gives us a negative 25. Negative 15x plus 15x. Oh, isn't that funny? 9x squared, and I wrote a 5. That would be a problem. 9x squared minus 25. Now, let's go ahead and use our formula over here, our generic one, where we have a plus b times a minus b. Going to multiply a times a, and we have a squared. A times a negative b gives us a negative ab. And a totally, you know what, these markers are brand new and they are just a fail. Let's see if this green one works any better. Negative ab, the inside terms, b times a, is plus ba, but we put that in alphabetical order and we have plus ab. And the product of our last terms, negative b times a positive b, is a negative b squared. Now let's see what happens when we collect like terms. Negative ab plus ab, those terms cancel each other out. And we have a squared minus b squared. We have three answers here, three different products that we've arrived at using three totally different problems. I'm not going to keep this one either. Here's your toss it away. What have we done? Do you remember the word that I mentioned earlier when we transitioned to the second special product? Do you remember what I said it was the difference of? Difference of two squares. What am I talking about when I say the difference of two squares? X squared is x squared. 4 squared is 16. 3x squared, used as a factor twice, is 9x squared. 5, or negative 5, it doesn't matter. You use that as a factor twice. 5 times 5, well, that's true, but it's going to be a negative. 5 squared is 25. A squared gives me a squared. B, used as a factor twice, gives me b squared. What's the definition of this? It's the difference of two squares. What is difference talking about? Difference is subtraction. So the difference of two squares, this pattern right here where you have a squared minus b squared, this is what you result. This is what results, or this is what the result is anytime you multiply together two binomials that differ only with the sign between them. You are always going to be able to follow this pattern. X squared plus 2 x, I don't even want to do that. I'm trying to take this a little bit further. Let me just use these two. These two terms are the same. They only differ with a sign. So their solution is going to be the first term squared minus the second term squared. 10x plus 2 times 10x minus 2 is going to be the first term squared minus the second term squared. 100x squared minus 4, and you can look at that and say, really? How in the world could that possibly be equal to this? Let me go ahead and use this as our very last example, where I multiply it out using FOIL. 10x plus 2 times the quantity 10x minus 2. First terms multiplied together, 10 times 10 is 100, x squared. The outer product, 10x times the negative 2, negative 20x. The inner product, plus 20x. And the last, positive 2 times the negative 2 is a negative 4. And you see that the outer and inner partial products cancel each other out, resulting in 100x squared minus 4, which is exactly the answer that we arrived at here, and it is the difference of two squares. 10 times 10 is 100, x times x is x squared. Subtraction is the difference. Negative 2 squared is 4, positive 2 squared is 4, so it's the difference of two squares. So you have, when you multiply two binomials together that are identical in every way except for the sign, you arrive at the difference of two squares. So we had two special products that we talked about today. These are both very, very important. It is helpful if you remember that the square of a binomial has a special pattern. It's a squared plus 2ab plus b squared. And the product of two binomials that differ only in their signs results in the difference of two squares. These are both special products. You don't so much have to memorize this one because you can always back it out. This one you have to recognize because you're going to, in our next chapter, we're going to factor binomials. Just like you need to be able to tell me that 36 can be written 2 times 18, 3 times 12, 4 times whatever, 4 times 9, 6 times 6. You need to be able to tell me, to be able to know what two binomials do I multiply together to get x squared, a squared minus b squared. And that's where knowing that you have the difference of two squares and this formula is true is very essential for you to know. So from section 8.7, you need difference of two squares. And this is a perfect square trinomial, and this is squaring a binomial. In this chapter, in chapter 8, we're going from here to here. This is chapter 8. Next chapter, we're going to be moving in the opposite direction. And these two forms will be very important because what we're doing here is we're multiplying to see what our product is. We multiply to see what our product is. Next chapter, we're going to factor. We're going to start with our product. We're going to move backwards so that we factor. So spend whatever time you need to on this section so that you thoroughly well understand how you obtain the difference of two squares and that you understand what your result is when you square a binomial. And I'll see you next time.